Thank you, everyone, for joining the session. I'm Bobby Seal. I'm a product manager in cloud networking here at Google. And Anton?
Hi, my name is Anton. I'm a network engineer with Twitter. I've been working on mostly on a backbone network, and I have been working with Google Cloud for about 4.5 years.
So today, I'm really delighted to have Anton describe how Twitter uses Google's portfolio of hybrid solutions to provide the best possible experience for their users. So, what is hybrid? In the previous portion of this webinar, our speakers talked about migration from monolith to distributed applications. This distributed applications and services can have parts running on Google, on other clouds, or even on-prem. Hybrid is essentially the connectivity glue that brings these distributed pieces together. It helps you take a pragmatic approach to adapt to changing market conditions and incrementally modernize your applications, taking advantage of the best that each world has to offer. Now, there are multiple layers that you can use to build this hybrid solution. As illustrated in this slide, there is a connectivity layer where you can either have private connectivity or even public connectivity. For private, you can leverage interconnects, direct or partner, or use virtual private networks. You can even choose to connect these distributed applications across the internet, provided you have the right security controls in place. In this slide, you can also see the hybrid load balancing layer, where clients can use our load balancers to load balance to backends not only on Google Cloud, but also to on-prem and even other clouds. Some of our customers choose to take a service-centric approach, whereby workloads on-prem are exposed as producer services that are accessible to clients and consumers on Google Cloud or even on other clouds. And there are multiple combinations of these that can be supported. So, what are some of the spectrum of use cases that customers use hybrid for? Some retain their workloads on prem but use Google's security solutions, such as Cloud Armor and Identity Aware Proxy, to protect them. Or they use Cloud CDN to provide the most optimal latency experience for their end users. Some are migrating to the cloud and they use weighted traffic splitting to do a phased migration. Others are looking for failing over from on prem to cloud during certain bad scenarios. And you have customers that wish to intelligently route their traffic to the closest serving region. This serving region could be a GCP region, it could be on prem, or even other clouds. And they wish to do so in a resilient fashion, taking into account the availability and capacity of the backends. But without much further ado, let me invite Anton to share how Twitter is leveraging this hybrid paradigm to meet its business requirements.
Let's first talk about hybrid connectivity. Twitter runs. Twitter needs to exchange massive amounts of data between our on-prem data centers and Google Cloud. Twitter has been working for some time with Google on provisioning terabits of capacity to support these workloads. Hybrid connectivity solutions can scale to high data rates and provide high levels of SLA when you're using compatible connectivity designs. Provision capacity can then later be sliced and provisioned to specific GCP region. Hybrid connectivity can also be used to provide high throughput access to GCP APIs. For Twitter, typical workflow would be Twitter writes data to storage GCP endpoint and then compute and GCP runs workloads on this data. To access GCP APIs, Google Private Access was an option that was available, but it maps all the API endpoints to a few pre-allocated IPs. Traffic from Twitter to on-prem will take the path to the endpoints in GCP region according to the best network metric. This might be a region that doesn't have resources for some of these workloads, or Twitter teams want a region that is has the best latency. Solution to this is to stand up private Service Connect endpoints in front of Google API endpoints in the specific region. That way, Twitter can route traffic deterministically to a specific regionalized endpoint. Another use case is separating workloads. Some workloads can be spiky and need to be physically separated from other workloads to prevent congestion. Solutions to this is to route them over separate GCP dedicated interconnect links by first standing up a dedicated private Service Connect endpoint for each workload. Advertise private Service Connect endpoint IPs selectively over the links dedicated to this workload. Traffic for the private Service Connect endpoint is limited to the bandwidth that is provisioned for the dedicated interconnect. This way, your workloads are running over separate links and not going to cause congestion. Another use case I want to talk about is hybrid load balancing. We at Twitter have two main use cases for Google Edge. We use GLB TCP load balancers and level 7 load balancers to balance between Twitter on-prem front-end servers and Google front-end servers. In both cases, we set up multiple VIPs with different routes going back to Twitter. Some routes go over Twitter backbone, some go over Google backbone. Before, Twitter user traffic wasn't terminating only on our front-end servers in our data centers or POPs across the world. With Google, we are able to stand up front-end servers in many more locations where we do not have physical presence. This way, latency from the end user to the front end for TCP and TLS handshake is lower, and overall request latency is lower, improving user experience. Another one is you can elastically scale the size of your Google front-end server's deployment based on the user workload and to accommodate changing user patterns. This could be due to like Twitter is becoming popular all of a sudden in the country or world events. I have an anecdote that I would like to share. One event that we had to deal with was a Big Brother TV show in Brazil. Viewers are encouraged to vote for their favorite contestant during the show and to vote on Twitter. All this simultaneous inrush of user traffic is causing a big spike in our workload. This is way above our normal workload that we see there. Normally, traffic from Brazil would terminate on Twitter front-end servers that are located in Brazil. These servers were provisioned to handle normal level of traffic, but not these huge spikes from the Big Brother TV show. Using Google front-end servers, we were able to quickly scale up the front-end capacity to handle this. We could shunt this peak traffic to Google front-end, and this way maintain low latency without having to provision additional physical infrastructure just for this peak traffic.
Thank you, Anton, for sharing the use cases from Twitter and how Twitter uses Google's hybrid solutions. So here is our key takeaway. Just as Twitter did, we invite you to try out our hybrid solutions for your distributed applications. Pick the layer that works for you. It could be connectivity, or you could look at load balancing with advanced traffic management, or you could take a service-centric approach. Now, speaking of service-centric approach, let me hand it off to Mark and his guest, who will talk more about Private Service Connect and how it can help you simplify and secure your service connections.